Okay, here's a quick problem on how to do a kind of a standard projectile motion problem. What's happening is there's a stone being thrown from the top of a building at an angle of 30 degrees to the horizontal with an initial speed of 20 meters per second. It's 45 meters above the ground, and they'd like to know how much time it's going to take to hit the ground, what's the final speed it hits the ground with, and how far away from the bottom of the building would it land. So these are our equations for projectile motion. Just our kinematics equations now accounting for the angle component for Vx and the angle component for the initial velocity in the y direction. We write down what we know in the problem, and then we take a look at a good equation to start doing the solution with. So if we take a look, since they've given us y values, that's a pretty good hint to start with an equation either this one or with this one. So you could try either one. Let's start with one right here for the displacement in the y direction. So if we write that out and then we come down here and we fill in the values that they've given us, notice that t is the only thing we don't know. Somewhat unfortunately, we might have to use the quadratic formula, but that's not a big deal. We can do that. If you need to be reminded about what the quadratic formula is, it's off here to the left. And we would just apply the quadratic formula to our equation of motion that we've written. And we'd find out, once you're patient and you do the math, that there'd be two possible roots for time. One would be negative and one would be positive. And obviously it's only the positive time root that's going to make sense in a problem like this. Okay? So calculating that time root out, we would come out with a time of 4.21 seconds. Great. The next question asks, what's the final velocity with which it hits the ground? Well, it's got a velocity sideways, and as time goes on, it's going to be moving faster and faster and faster in the downward direction. But how do we combine those two velocities together? Well, we're going to use triangle trigonometry, all right, with what you know. And basically, we know that the velocity in the x direction doesn't change because there's no acceleration in the x direction. So for the whole problem, we could take our initial velocity times cosine theta. For the whole problem, the x velocity is going to be 17.3 meters per second, an unchanging value. But the y direction, right, will change because the object is accelerating downward. So to get our y component of velocity, we need to use our equation of motion for accelerated free fall, and we would have 20 sine 30, that's the y component of the speed thrown upwards, minus the 9.8 times the total time in the air, since we're interested at the end of the problem, of 4.21 seconds. So we find that the downward component of the velocity is 31.3 meters per second. So sketching out a little triangle to get our mind around what's going on, moving this fast sideways and moving this fast downward at that point, we can combine those two velocities together using our triangle trigonometry, and we end up with an overall final velocity of 35.8 meters per second. But remember, velocity should have a direction associated with it, so we also need to say the angle with which we'd strike the ground. So for that right triangle, and this angle theta, which is the same as this angle theta, the tangent theta is the opposite side over the adjacent side, or the Vy over the Vx. And if we work that out, and then use your calculator, make sure it's in degrees mode, we come up with an angle of 61.1 degrees to the ground that the object would be striking the ground with. Okay, so that answers question number 2. Question number 3 was how far away from the base of the building did the rock land? So how far away is going to be our delta x, or our range, right, from the base of the building. So if we take a look at the range from the base of the building, right here, that's just given by the x velocity times the time, since there's no acceleration again in the x direction, which is our vi cosine theta times our time in the air. So that gives us 20 cosine 30 times the 4.21 seconds, or the rock would land 72.9 meters away from the base of the building. All right, that should be a problem that could help you get started on thinking through the rest of the projectile equations.